Okay, so I'm going to talk to you today about some of the ongoing discussions around a new disease framework for MS and the phenotypes, which you may also hear described as subtypes or clinical course descriptors. These are my disclosures. Particular note that I am a member of a working group right now that is working on the clinical course descriptors for the International Advisory Committee on Clinical Trials in MS, which is a joint initiative sponsored by the National MS Society and ECTRIMS. So we define the course of MS. You might not wonder why, but we're trying to ensure some clarity and consistency so that when we talk about different groups for our epidemiologic studies or our clinical trials, that we all know who's being involved and to whom our results generalize. For clinical trials in particular, we want our patient populations to be reasonably consistent and homogeneous, so we understand to whom the results apply. And it helps clarify communication. So early on, there was survey-based work that produced a set of 4 descriptors, the relapsing remitting MS that you see at the bottom of the slide, primary progressive, secondary progressive, and progressive relapsing. In 2013, Fred Lublin and Steve Reingold led an effort to move beyond survey-based standardized definitions. And they sought to do this to reflect some changes in our understanding of how we describe the disease, to incorporate new tools, so what we knew about imaging, and to assess whether we could incorporate additional information, such as biomarkers that were related to fluids or neurophysiologic measures. So what they came out with is what we're currently using, which I think will be familiar to some of you, particularly those who are clinicians, in which we currently use the relapsing forms of MS as well as progressive forms of MS. And so if you look at the relapsing remitting box in the corner, which is green, we can classify those individuals as having active or non-active disease, and we're assigning a particular time frame to that, so usually over a last year. And that can be based on both clinical activity in the form of relapses or changes on imaging. Similarly, if we look at progressive disease, we can look at whether it's active or not active in that last time period, but we add in the extra layer of whether that individual has progression or no progression. So this is what we've been using practically, but there are some limitations to this classification, although it reflected an improvement on the previous descriptors. So it really doesn't do a very good job of reflecting underlying biology. So by example, we could have 2 people, both of whom are labeled as having secondary progressive MS, but may have vastly different underlying biological mechanisms which are dominant in terms of driving their progression. And within an individual, if we look over at the right-hand side of the slide, we have one person who may keep the same label for a decade, but the biologies that are driving their clinical presentation may be changing over time. Why should that matter? Well, different biology gives us different prognosis and potentially different response to treatments. And in particular, I think it helps limit the way we think. So George Orwell, if you had to read George Orwell in high school like I did, said if thought corrupts language, language can also corrupt thought. So if we use language that doesn't appropriately describe disease, then it can limit our thinking in important ways and reduce our ability to innovate and develop appropriate therapeutics. So a working group, of which I was I will say, very small member in this group in terms of the heavy lifting that was done, opted to try and propose some of the thinking that should be behind a new mechanism-driven framework. Wei Young is a member of that group, and Jen Graves, whom you heard from yesterday, was also a member of that group. And so the figure that I'm showing you here is an adaptation of the paper that was published in Lancet Neurology, in which we posited that the clinical expression of the disease and progression really reflected 4 broad factors. 1, injury mechanism, and things including like mitochondrial injury, oxidative stress, and demyelination, which you've heard a lot about so far at this meeting. Compensatory mechanisms such as repair and remyelination, as well as roles of biological aging and underlying brain reserve. And you'll see in a circle that these processes are modified by multiple factors. So you just heard a lot from Annette Lango-Gould about race and ethnicity and social determinants of health. These are all factors that influence the final interaction of those factors to produce our clinical expression. Fortunately for me, Mark Friedman introduced this figure to you yesterday, so I'm not going to spend a lot of time on it. And what it really is meant to highlight, there are a lot of different potential pathobiological mechanisms that can contribute to disease. Some of these we can measure in clinical practice now, some we cannot, but would hope to be able to do in the future. And these are things that we want to be able to incorporate into a future framework. So our challenges with any framework are that our understanding of biology of the disease is incomplete, but it's evolving. It's very clear that our current framework to describe clinical phenotype is inadequate to meet the needs of our research, to move forward our understanding of the disease, and to allow us to make appropriate treatment choices. So we have the opportunity to think about integrating stages in phenotype. Another example, which I haven't talked about, but I think I actually have a whole minute to talk about, is thinking about what they've done in cancer. So if you think about individuals who are diagnosed with breast cancer, for instance, they may be described as having stage 2 disease, which describes an overall severity measure, but we then describe them according to things like their hormone receptors and Herceptin receptors. And so based on those biologies, we can provide individuals, along with their stage, with a prognosis and a treatment plan tailored to their biology. That's an opportunity for us that if we can do it, one day we can test therapies based on their biologic mechanisms rather than just the clinical appearance of the individual in front of us. This is not an easy task that we're going to have to do. This is something that we need to continue discussing and working on and make sure it's acceptable to all of the stakeholders, figure out how to describe it. So this is very much a work in progress.